I figure you can never see enough integrals. It's one of those things that it's just the more you see, the more experience you have, and the more you'll be able to solve. And I got these from Ari, and who's one of the viewers, and I don't think I have covered something like this, so I decided to do the problems he sent me. So the first one, actually, I'll do it in the order different than his. I'll do it in kind of what I think is most difficult to least difficult. Or maybe that's subjective. Let's see. The first one, y is equal to the integral. And this is what is maybe new or different for a lot of you. The upper bound is e to the fourth. And that might look daunting, but that's just a number, right? E is 2.71, whatever, whatever. You take that to the fourth power, you're going to get some other number that's, I don't know, it's going to be some large number, but it's just a number. And even though it looks like e to the fourth, it looks like a variable, it's just a number, so it shouldn't intimidate you. And then the lower bound is actually a function of x. And once again, this might be daunting, but all this does is say, you give me an x value, I'll take e to that power, and that's going to be the lower bound. So our resulting answer is just going to be a function of x. So let's see what the rest of it is. And then the actual problem is dx over x times the square root of ln of x. So once again, this is, might be confusing. The dx is up there. It's not on the side. We have this natural log under a square root sign, this x here. How do you even approach it? So the first thing you should always think about is if you have a natural log sitting here, do you see its derivative anywhere? What's the derivative of the natural log? Let me write it. Derivative of the natural log of x. Well, we know that already. That's 1 over x. And is that sitting here anywhere? Yeah, sure. This is 1 over x. 1 over x. Let me rewrite this integral. So this is equal to y is equal to the integral e to the x, from e to the x to e to the fourth, of 1 over x times, I'm going to write this as ln of x to the minus 1/2 power dx. And there you see 1 over x, so you have a natural log of x raised to some power, but you have the 1 over x right there, so it works out. So all we can do here is use substitution. And if you get really good at this, you don't even have to do the use substitution. You say, oh, I have something and I have its derivative, so I could just treat this like an x, or like a u, really, and take its antiderivative. But we'll do the u substitution just so you don't get confused. So you let u equal ln of x. So if u is equal to the natural log of x, then what is the derivative of u with respect to x? Well, that's equal to 1 over x. We already knew that from right there. And we could say that du is equal to 1 over x dx. And there you have a 1 over x dx. In fact, I could put this 1 over x right here, and you'd have a 1 over x dx. So let me redo that just because it's important not to get confused with these problems. So you get y is equal to, and you normally wouldn't have to rewrite it this many times if you were doing it, but I just want to make it clear. So this is ln of x to the minus 1/2 times 1 over x dx. I just wanted to put it in that arrangement. So this right here is u, and this right here is du. So this integral can be rewritten now in green as y is equal to the integral from e to the x to e to the fourth times u to the minus 1/2 u to the minus 1/2 du. And now this should be a pretty straightforward integral for you. You essentially kind of take the inverse of the derivative. So when you take the derivative, you take your exponent, multiply it out front, and reduce and increment it down by 1. When you take the antiderivative, you do the opposite. You increment this up by 1. So this will be equal to u. If you increment this up by 1, you get u to the 1/2 power. And then you multiply by the inverse of this. Right? So you get 2u to the 1/2. And just to confirm, and I like to always do a reality check, let's take the derivative of this. 1/2 times 2 is 1. And then you decrement this by 1. And you get minus 1/2. So you'll get u to the minus 1/2. So that works. So this is the antiderivative of that. But we're taking a definite integral, so we don't have to write a plus c out there. And we just have to, so we say y is equal to this expression evaluated between e to the x and e to the fourth. And so that this is equal to, you evaluate it at e to the fourth first, and then subtract it, evaluate it at e to the x after that. So evaluated at e to the fourth, it's equal to 2 Oh, sorry, I forgot. I have to remake my substitution because this is in terms of x, while this is in terms of u. So this is equal to what was u? U was the natural log of x, right? So this is equal to 2 times, the natural log of x to the 1/2 power. And now we evaluate this from e to the x, from e to the x to e to the 4th power. And what does this become? So this is equal to, we evaluated at e to the 4th first. I'll switch colors just to ease the monotony. So we get 2 times the natural log of e to the 4th, to the 1/2, minus 2 times the natural log of e to the x times, or to the 1/2 power. And this simplifies pretty well. What's the natural log of e to the 4th? So, what number do I have to raise e, what power do I have to raise e to get e to the 4th? Well, I have to raise it to 4. So this is 2 times 4 to the 1/2 minus 2 times, once again, the natural log of e to the x. Well, what power do I have to raise e to get e to the x? Well, I raise it to x. So this is equal to 2 times x to the 1/2. And so this is equal to, this is equal to the square root of 4. 4 to the 1/2 is the square root of 4. So it's 2 times 2. We're assuming positive square root. So we get 4 here, right? Because this is 2. 2 times 2 is 4. Minus 2 square roots of x. And that's our answer. And that's what y is equal to. So y is still a function of x. Let me do one more. So he gives us the integral, and this is now an indefinite integral, e to the sine theta times cosine of theta, d theta. So once again, you see, you have like, wow, I'm taking an exponent. I'm to have a trigonometric function as exponent. That's difficult, and have all these things here. But what you see is, you have a function here, and you have its derivative, right? The derivative of sine of theta is cosine of theta. So, one, you could just, like I said, you could do the shortcut where you don't even do use substitution. You say, oh, well, then I could just treat this like an x. So the antiderivative of e to the x is e to the x plus c. But then it becomes e to the sine theta plus c, and you're done. But I'll do the u substitution so you don't get confused. So let's say, so when you see something, you see its derivative there, you make that thing the u. So we say u is equal to sine of theta. And then you get du d theta is equal to cosine of theta, or du is equal to cosine of theta d theta. D theta, so this right here is du, this right here is u. So then this integral simplifies to e to the u, and then cosine theta d theta is du, e to the u du. And these are the most fun integrals because the derivative or the integral of e to the u is just e to the u. So this is equal to e to the u plus c. Once again, this is an indefinite integral. And then we just reverse the substitution. What was u? U was equal to sine of theta. So this is equal to e to the sine of theta plus c. And there you have it. And then this is the last one. And I'm not sure if I'm reading this one right, but I think I am. So so he has y is equal to, and once again it has these funny looking boundaries, e to the x, from e to the x to 0 of sine of 3t dt. So this one isn't a u substitution. This is really, what function's derivative is sine of theta or sine of t? Well, it's cosine. So if you see a 3t here, you say, well, what's the derivative of cosine of 3t? So d dt of cosine of 3t. You do the chain rule. You take the derivative of the inside, so that's equal to 3, times the derivative of the whole thing. The derivative of cosine of 3t, or the derivative of cosine of t, is minus sine of t. So the derivative of this whole thing would be minus cosine of 3t. And then you get, so this is equal to minus sine of 3t. My baby's waking up and he's making me, I have a live studio audience here. Maybe he'll pick up something about integration. So I have minus 3 times sine of 3t. That's the derivative of cosine of 3t. So we just have to make this look a little bit like this, and we're all set. So what we could do is we could multiply and divide by -3, right? So we could rewrite this as y is equal to integral e to the x to 0. So let me divide. So divide by -1/3, and then you multiply by -1/3. Right? This just comes out to be 1, right? -1/3 times -3 is just 1, so I didn't change the integral, times sine of 3t dt. This right here, that's the derivative of cosine 3t. We just showed that right there. So this is, and we could take this, any constant you can actually take out of the integral. We don't have to even. So this is equal to, so y is equal to, but I'll take it out, -1/3. And then this is a definite integral. So the antiderivative of this right here we just showed is cosine of 3t. And we have to evaluate this from e to the x to 0. So this is equal to 1/3 times, if we evaluate this at e to the x, or actually we want to evaluate it at 0 first. So cosine of 0, so cosine of 0, we know actually that that is equal to 1, right? Cosine of 3 times 0, that's just cosine of 0, that's equal to 1, minus cosine, this is a -1/3, minus cosine of 3e to the x. So it's a little messy looking, but I think that's the answer if the problem statement was correct. So we get, so this is equal to, if we multiply all of this out, -1/3 times this is -1/3, -1/3 times this is plus 1/3 cosine 3e to the x. Hopefully you found that helpful, and thanks Ari for sending the problem. See you soon.